So this is like a demo. There is another demo where you can basically uh, mint an NFT in a gasless way on any other network. Uh,
Yeah. While you put that, I think let's stop for a second for any questions
yeah.
you might have. Anything on this, on the demo, on how the integration steps look like? Go ahead.
So you need to sign what data that you're dispatching on your target contract as well, right? So that's how you authorize this call that I want to sign this, and it is up to you uh, to decide the security that what all things that I should sign. Because let's say if I just to give you an example, we saw the case of die, right? Let me go back to this contract. So let's say if it's funny because we actually asked this as like one of the interview questions, where let's say there is this permit call, and standard way you will be signing these things like holder, spender, nuns, expiry, and allowed. So let's say when signing you miss out a spender, right? And you just give the signature. Now, when you are making a transaction, this transaction can be front run, and someone can give your signature with a different spender address, right? Yeah, exactly. Because the way nuns works on the contract is like you verify the nuns, and then when your transaction happens, like after the signature verification, there was a step of updating nuns, right? So basically, it updates nuns to like +1, so that next time when the same signer wants to do a transaction, they need to get the nuns from the contract, right? So nuns, you need to sign and pass it to the contract, because let me go back to the actual signature verification logic. So here what I've done is there is a struct, right? So I have specified the struct meta transaction, and there are 3 parameters. So I'll be signing this whole message, right? Like nuns from an function signature, which we saw in MetaMask. Now let's go to the signature verification part where there is this verify method, right? So it verifies here that this is the nuns that you have. So this is the nuns which comes for this user address, right? Like from the contract state. So if you did not provide this nuns by reading from the state, the signature verification would fail with. Yeah, so after the verify step, the nuns is being updated here. Huh. Do you mean the state of Biconomy object? Uh-huh. So nuns is so let's say if a new signer comes in, by default the value is 0, right? Like for uninitialized state. So it is start from 0 for all the signers. Another interesting thing is, let's say you as a signer dispatch one transaction, and relay has submitted this transaction on chain, but this transaction has not been confirmed yet. But you don't, as a user, you don't know a lot of things, right? So you get frustrated and click the button again and sign the message, right? Or maybe you do another transaction thinking that that transaction has already been done. So now what will happen is this transaction hasn't gone through. So now that nuns has not been updated to +1. So when you sign another message, you will get the same nuns from the contract. Uh, and now both of these transactions are in the mempool. And if one of the transaction gets confirmed before the other, then the another would fail with signature mismatch, right? So this challenge a lot of DApp faces, like, because if there is a same signer, you need to wait for that transaction to be mined. There is a solution for this, which we call like a 2D nuns, or you use like a none space for a particular signer. So instead of like having nuns as just a mapping like user address and you get the nuns, instead of that we call it like batch ID and batch nuns. So for the same signer, you can specify different batch IDs, so that it will query. Batch ID is like a none space, so from that space it will query the nuns, and it will send the transaction. So for trusted forwarder approach, it is actually using that 2D nuns. Huh. Yeah. Not really. So this is just like an example contract. It could have been like, any other contract. So let me, huh. Yes, 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 yes. That is a standard. So let me go through. So basically, in the custom approach, so here we inherited from this contract, right? EIP 712 meta transaction. That also give us the message sender. In case of trusted forwarder, what we recommend is, because it has a trusted forwarder contract, right? Which GSN also uses, or even OpenZeppelin has that standard now, that ERC 2771 context. So in this case, you will either inherit from ERC 2771 context contract, or you will inherit from base relay recipient from GSN. And let's take a look at those contracts as well, so that we can break it down like both the flows. Let me just, okay, let's take, okay. So in ERC 2771 context, or even if we search for base relay recipient, what happens is there is this method which is a standard, right? Like, because you need to know whether it is like coming from a relay. So in this case, what it does is it checks if the message sender is trusted forwarder, because that's how the internal transaction flows like, right? So it is the same way of checking, like whether it is coming from a same contract or it is coming from a trusted forwarder, in as a way to know whether it is coming from a relay or not. If it was coming from a relay, then relay would have appended the user address as 20 last bytes of the call data. Huh. Huh. So yeah, so this is already used in trusted forwarder approach. So let me open this contract as well. Because if I want to use the exact same contract, uh, it relies on the trusted forwarder implementation, right? So basically, if you look at that code, uh, this method is the same. Like, it checks whether it is coming from a trusted forwarder or not. But in custom approach, there is no trusted forwarder. Relay can directly call the DApp contract, and there is also a reason why it can call, because if you have a method in your contract which already has like user signature as a parameter, right? So you can directly pass that user signature and then have the verification logic within. So we give both the options, and we recommend base contract for both the options which you can use. Uh, any other questions? I think I'm almost done with the demo. Uh, maybe what else I can. Sorry.
NFT wala.
But it's the same thing, right? I can transition.
Yeah, so this demo that Chirag has just shown you, it's publicly available. The repos there, you can play around with it. We'll just move on in the interest of time as well. And anyway, we'll be hanging around after, so you can ask any questions you have to Chirag or even me. Uh, so we already talked a lot about gasless and how essentially you can simplify the transaction layer experience for end users, right? The other aspect here is cross-chain composability, because right now we're in Polygon HackerHouse. There's Ethereum, which is like been around and is going to be around, and there's also a lot of different other rollups. There's also a lot of other alt L1s, and I think in the last 1.5 years, we've all kind of realized that the future is definitely multi-chain, whether that is just ETH and its L2s or other alt L1s as well. The need to kind of move your funds around on all of these chains is definitely going to exist. Now, the problem with that is that moving your funds from one chain to the other using the native bridges is not easy. So native bridges use kind of a rapid mint functionality where, say, you use the Polygon POS bridge to move your funds from Ethereum to Polygon. You deposit on the Ethereum side, the token is locked, and then a wrapped representation is minted on Polygon, right? Now, that's well and good, but to come back, you need somewhere around 15 minutes to hours. When we are talking about chains like Arbitrum and Optimism, due to their optimistic rollup in architecture, it takes 7 days for the challenge window to get over. So essentially, you're waiting for 7 days for your funds to come back to the L1. So interoperability is key for us to kind of keep building dApps that are, accessible to as many people as possible. There's also the problem that these native bridges usually only connect 2 chains. So the POS bridge connects just Polygon and Ethereum. Similarly, Arbitrum, Optimism have native bridges that connect only Ethereum and that rollup, right? So what we did is we built out Hyphen, which is a cross-chain liquidity bridge. The architecture is essentially that we have deployed smart contracts on all of these connected EVMs. So as of today, we are live on Ethereum, Polygon, Arbitrum, Optimism, BNB Chain, Avalanche, and Phantom. So 7 chains, 7 smart contracts, each has liquidity pools with different assets, mostly stable coins and ETH. How a transfer using Hyphen works is that the moment you deposit into a liquidity pool on the source chain, the deposit event is emitted, and we have watchtower nodes that are listening for these deposit events. And these watchtower nodes then tell these executor nodes, which are kind of like modified relayers. So these relayers then send the funds from the liquidity pool on the destination chain directly to the user's wallet. This allows transfer of funds to be super fast. Most of the transfers in Hyphen are done in like 30 to 40 seconds. And we've also built out APIs, SDK, and even a plug-and-play widget that allows any dApp developer to get the benefits of cross-chain interoperability inside their application. In Web 2, you don't open Swiggy and then open a second app to do payments. So you should not have to go to a third-party bridging website to move your funds around in Web 3. Like, all bridging should happen in dApp and as much under the hood as possible, right? We can actually take a quick look at the docs here. So we have the SDK that you can integrate to, it's a JavaScript SDK that you can integrate to take things under the hood with Hyphen. We also have APIs and the plug-and-play widget. The widget takes around 5 minutes to integrate into your application. With the widget, obviously, you're still asking the users to do the transfers themselves. But with the SDK and APIs, you can abstract that under the hood as well, right? With the widget, we also have this kind of quick 2-minute video here that you can use to, go through the integration. Beautiful, this is hung. I'll give you I'll show a player video actually that shows you what an in-dApp integration with Hyphen looks like, and how you can benefit from having a bridge inside your application. So this is Perpetual Protocol. This is actually one of the largest dApps on Optimism. So what they did was they wanted to allow users who didn't have funds on their chain to onboard without having to leave the application. We've had dApps on Polygon as well enable a similar user flow. There is an NFT gaming project called Zrun who have also integrated Hyphen onto their UI. So as you can see, all the user needs to do is just open the pop-up, bridge their funds. Funds will get transferred in 30 seconds. This entire video is a minute long. Funds get transferred, and then you can go back to using the application. We'll talk a bit more about what we are building now, because right now still the users are doing these things, but in the dApps of the future, as we were discussing earlier, more and more of these things will be happening under the hood. The user just will click swap. User doesn't need to know that the swap is happening cross-chain, right? User just clicks deposit into a vault. User doesn't need to know that there's 2 steps in that deposit. That first you bridge your funds and then you do a cross-chain smart contract call to actually deposit into that vault. So these are the things we're kind of trying to do to abstract things away further. So I'll move on to a couple of case studies first. So this one is with Zedrun. So Zedrun is one of our old clients. Like, they integrated with Biconomy in 2020, and they went gasless very early on in their own product life cycle. And like, their team tells us that they believe it's a key part of why they have succeeded as much as they have, because we've actually had a lot of other projects come to us and tell us that we want to have a transaction flow like Zedrun. So yeah, some stats from that is we've relayed over 8.5 million transactions for Zedrun, saving over 210K in gas costs for Zedrun users. We've saved over 1,500 hours of Zedrun users' time with the Hyphen integration on Zedrun. And actually, Hyphen obviously we launched later, so Zedrun were already live before that, and their users were using the native Polygon bridge to move their funds around. And after integrating Hyphen, in the next 1 month, Zedrun saw a 50% rise in user deposits compared to the trend they were seeing earlier. So it just goes on to highlight the value of a good UX and the value of simplifying things for users and just keeping them inside your application, retaining their attention, and lowering those drop-off rates. There's a few more case studies we put here. This is another very old case study, actually, with Idle Finance, where they did gasless deposits into their vaults and saw an increase in user count by around 40% after going gasless. Similarly, Perpetual Protocol, this is back when they were still on Gnosis chain. Gnosis chain used to be called XDAI back then. And as you can see, the spike in trading volume here is after integrating with gasless to reduce the friction that is there for users to trade on perp. Yeah, we again, this is an old slide, so a lot of projects we are currently working with are not here right now. Maximum number of transactions we are seeing as of today is, I think, Decentraland is one, DYDX is another who we see a lot of volumes from. But yeah, we've had amazing testimonials from different projects who've been using our infra. So this is what all we've done so far, what people have thought about what we've done so far. But what are we building now? So currently, we have gasless out, we have Hyphen out. But as I said, with Hyphen, we are building new cross-chain primitives to allow things like cross-chain smart contract calls. And on the gasless side, gasless at its core is relayer infrastructure, right? And relayer infrastructure is going to be key in this new narrative in the EVM space called account abstraction that I'll let Chirag talk about. But yeah, that's key part of what we're building right now. Further improving cross-chain composability and working on account abstraction. Chirag.
Hello. Thanks, Rick. So yeah, I mean, there are lot of different possibilities and new narratives because of the ecosystem where it is right now. So like some of the things Rick mentioned, it like which is like a one-click experience for an end user, where imagine you do the approval, you port your tokens to some other chain, you swap your tokens to new different other tokens, and then you sort of like approve for the staking contract for that token and also stake your tokens there, right? So this cross-chain batching and cross-chain transaction Legos are possible with like new type of a vehicle called like smart contract wallets. So and I'll also like cover very quickly like what account abstraction is. I think we have like maybe 10 to 15 minutes. So basically in Ethereum there are like two kinds of accounts, right? Like one is like an externally owned account, which is your MetaMask, which is governed by like private key and public key pair. And there is like contract accounts, which has like, has its own like custom logic and in order to like trigger any transaction on a contract, you need an EOA, right? So basically account abstraction is, you know, differentiating your account from a signer. So in case of EOA, your account is a signer where it, uh, signs a message and then ECDSA signature verification happens, like you recover the signature and it verifies whether it is, coming from this signer address or not. In case of account abstraction, it is basically the, you have like a signatory on a smart contract wallet, which can basically like send out transactions, like just authorize a transaction by just giving a signature. So signer is not the account itself. The account is basically a smart contract wallet, and it is basically about like converting this EOS into smart accounts or smart contract wallets. In the sense like EOA gets abstracted away, right? So that's the whole concept. And in order to like send out transactions to the smart accounts, you need like a relayer ecosystem, right? So because the contracts cannot like initiate transactions on themselves. So in this case, like EOA just gives the signature and then relayer sends out the transaction. So we can see that in like different onboarding flows. I'll just quickly cover like what we have been up to and what are the cases that as we call it like transaction Legos, and what could be possible with like these kind of wallets, because so this is just like current flow of an account abstraction. It is not like an EIP, which is not which is actually like deployed on a protocol level, but it is a way of sending transactions on this smart contract wallets. So basically, there is like a relayer or a bundler which sends a transaction to a verifying contract, and this contract will send the transaction to your smart contract wallet. And basically, the flow is like, this is the deployment of wallet, but this is the side which is in the essence of it. Like there is an EOA, which is just a signer, and then there is your account on the right side, and you send or dispatch this signature or a signed user operation in case of account abstraction transaction, and then relayer or bundler will take care of dispatching this transaction on chain. And relayer can directly call your smart contract wallet, or there is an validator contract which calls your smart contract wallet. And the benefits are a lot, right? Compared to an EOA where security is loose. Like if you lose your private key, you cannot like change the signer on your EOA, right? But in case of account abstraction, since the account is not same as a signer, I can actually change my signers. I can actually have multiple signers. I can enable like multi-sig within my wallet, right? I can have like social recovery. I can like pick like some of my friends to recover a signer if I lose my key, right? So there is security angle around like the security of EOS basically. And then there are other benefits where you can pay gas fees in ERC20 tokens from your wallet, and you can do transaction batching. So you can send like a batch of 10 transactions on your smart account, and then they will go as a single transaction. And this single transaction is not in the context of just one chain. It can be like a cross chain, contract to contract call. So for example, you as an EOA just dispatch or sign a transaction, which will tell that, okay, I want to invoke my smart wallet. And these wallets are actually counterfactual in nature. So even if you haven't deployed the wallet, you can see the same address on, let's say, Binance Smart Chain or Avalanche. And for your end user, it like opens up a lot of possibilities. Like let's say, for not very Web3 native user, you can just deploy smart account for them and show that wallet address, right? And then you can have like a widget, or you can build a Chrome extension, right, which is actually like a wallet and provide like fiat on ramps for these users, which will directly deposit funds to their smart account, and then different kind of transaction flows can be invoked. So this is just a deployment process of a wallet, where you use like a wallet factory contract, which deploys a clone or a copy of a particular logic contract, right? And so all of these proxies are your smart wallets or smart accounts. And this is actually happening on some of the L2s like Starkware, ZK, ZK Sync, etc., where account abstraction has already come like at the protocol level, where there is no concept of EOS, and Ethereum is going in this direction, and everyone should be like thinking about it or developing on top of it. Uh, so this was the example where, let's say, there is a smart wallet on like another chain. There is a smart wallet on source chain as well. And I just trigger or authorize one transaction, which, sorts of like move my token liquidity from my smart wallet to same smart wallet, like same address on another chain. And then it does, like any intent. So you can call it intent, that what I want to do once I transfer my funds to another chain, right? So imagine like sending like wrapped ether from Ethereum to Polygon, and also buying a NFT, or it can be like anything, like staking a token on another chain, right? So all of this can be like happened in like one click as a single transaction. So this is like very intuitive for the end users, and it is also like in line with the where like Ethereum is heading with the concept of account abstraction. So this was just like a very high level overview, but if you want to like check in details, we can have a chat after this call. You can go through the documentations. I think we'll share this references, right, later on.